Back to a session. Today let us see functions. So what is this function? In the previous session we have seen the relation. So now I will try to connect this relation with that of the function. So before that I will just tell you, we have started with sets and then we have seen what is a Cartesian product. And then we have moved on to relation. And finally from this relation we will move on to functions, right? So the origin of this function is, it comes from sets. From the sets we see what is a Cartesian product, and this Cartesian product is extended to relation. Further this relation is extended to function. So there is a connection between all these terms, right? So now before we enter into function, let me give you an analogy for a function, right? So function in the sense, even before the analogy, I'll tell you we have a machine, right? So this is a machine. So this machine may be either a CPU or a calculator, whatever may be, or your mobile phone. So whatever this is a machine. So it does some process. Right? Whenever we have a machine, it does some process, and to undergo the process we need the input. So we'll be giving here the input. So let the input be this, and once if we give the input, the machine does some process and it executes some function and it gives the output. Alright? So it gives the output. So this is a very simple example of a function. So what is a function? The function does some transformation or some process it undergoes. So how does it undergoes the process, or how does it works? So we'll have to give the input, and correspondingly that input will be taken into the machine and it will do the process. So whatever may be the process, whatever may be the rule, whatever thing it will undergo it, and finally output will be given. So this is the rule of a function, right? So a very simple example, if we take a calculator, if I give the input as 2 and 3, two numbers, and if I want to undergo multiplication rule there, so the machine will, or the calculator will perform the multiplication between two numbers 2 and 3, and it will give us an output as 6. So now this input will be called as the domain set, right? So domain is nothing else but all possible values of the input for any machine, and the output is the range. So range, it is nothing else but all the output possible values of a system or from any machine, it will be called as a range. So in a similar manner the function also works. So the function it maps from one term to the other term. That is nothing else but function. Here is, this is a function, right? So this is a function, and once if an input is given, it correspondingly maps to the output, or it gives the output. So likewise, if we see here, we have a function, right? So let x and y be the domain and codomain of the two sets, right? So I'll now give you the analogy of the function, right? So analogy of the function is that, even before that I'll just tell you what is a function. So now here we have domain set and codomain set. So this is a domain set x and this is the codomain set y, right? So now we'll have a function, which means that here I may have values, right? I may have values here also. In the codomain set I may have values. So let these values be a, b, c, and let this be 1, 2, 3, 4. Now the function, what it says is that every value of your domain set has to be mapped onto your codomain set under the function ef, right? So it will be mapped like this, right? It will be mapped like this. Mapping will be done like this way, right? So this is a function. So what is a function? A function says that for every element in the domain set, we have an image in the codomain set under the mapping F. That is what function says. Or even in terms of relation, if I want to say that this ordered pair, that is under the mapping F, this A point of the domain set has been mapped onto 1 in your codomain set. So I can write it to be as ordered pair A comma 1 which belongs to F. So that is what the function says. Now we will come on to the analogy part. So what does this analogy part say here? Right? So for us to have a better understanding of the function, let me give you a thing like I have child here, right? Here I have child, and or I can have children here, and I can have girls or boys, whatever may be the thing. So for say for example, children are Sita, Ram, Shyam, then Suresh, and so on we have here. So right, all these are the children, and the girls we have here. So girls, let them be like Nancy, right? So here Suganya, and then here I can have Chitra, then we can have Divya, then Nivya, right? So now I will say an analogy of this. So now the relation is nothing else but, or the function here, it is a mother, right? So how this transforms, let us see. So here in the domain set I have got children, and in my codomain set I have got girls. Girls are nothing else but they are the mothers, right? So how this maps or how this transforms, that's a very good example here. See here I have Sita, Ram, Shyam and Suresh are the children in my domain set, and these are all girls in my codomain set. Now here Sita, Ram, Shyam, Suresh, since because they are children of the mothers here, right, they have to be mapped. So Sita's mother may be Nancy, Ram's mother may be Suganya, or even Ram's mother may be Nancy. So the mothers may have 2 or more children, but then 2 or more children, right, or the other way I can say that 2 or more children can have one mother here, or here 2 different mothers cannot have a child. Same child cannot be assigned to the 2 or more mother. See here for example, I have Sita. So Sita's mother, let it be Nancy. Ram's mother, let it be Chitra. Shyam's mother, let it be Divya. And Suresh's mother, let it be again Divya. Nothing wrong in that, which means that Shyam and Suresh mother is Divya. So now see here, this is a function. So each and every element of my X has been mapped onto my codomain set under the girls codomain, and function is nothing else but mother. What did it say? So Sita's mother is Nancy, Ram's mother is Chitra, Shyam's mother is Divya, and Suresh's mother is also Divya. So this is possible, that is 2 children can have same mother, but mother can, right, 2 mothers cannot have same child, right? So that is not possible. See, of course, practically if we think also that it will not be possible, right? So 2 mothers cannot have a same child, but 2 or more children can have same mother. That is possible. In a family, a mother may have 2 children or 3 children and so on. So likewise it can be mapped. This is a very good example. This is called as a function. See again, I'll tell you, here we have children and here are the girls, and we are mapping this. So function says that each and every element of my domain has to be uniquely mapped onto my codomain set, So likewise, the ordered pair, that is A is mapped onto 1 under the function f, B is mapped onto 2 under the function f, C is mapped onto 4 under the function f. This is the definition of a function. Now the analogy part says that in my domain part I have children and in my codomain part I have girls, and the function what it says is that it is a mother, which means that each and every child should have a mother, right? So it is not necessary that they'll have a unique mother, right? So sorry, here Sita may have Nyansi, Ram may have Chitra, Shyam may have Divya, Suresh may have mother as Divya. So these Shyam and Suresh belongs to same mother Divya. That is, Divya has 2 children, Suresh and Shyam respectively. So this is a very good example. See, this I cannot have. This is a function, but then we see here, no, I'll give you an example. I have 1, 2, 3, 4, A, B, C, D, E, F, I may have. So this is my x and this is my y. See, now look at, let this be the function f. Now this 1 is mapped onto A, 1 is mapped onto B, 2 is mapped onto C, 3 is also mapped onto C, 4 is mapped onto D. Is it a function? Now tell me. So no, I will say that it is not a function. Keep this analogy in your mind always. 2 or more children can have same mother, but then 2 or more mothers cannot have a same child. So that is the thing. So this is not possible. This is not possible. That is, 1 cannot be assigned to A as well as it cannot be assigned to B. So therefore, it is not a function, right? Understood? This is not a function. And also one more point, each and every element, that is, see, again I will give you an example, like we have domain, codomain, x, y, this is the function f, 1, 2, 3, here we have A, B, C, D. And now here see, 1 is assigned onto A and 2 is assigned onto B. So now look at this domain. Oh, I have been left out with the element 3 free. It does not have any image on my codomain set. Is it a function or not? So you may be wondering. So you just think of your analogy. No, in the analogy domain set I have given children, and in my codomain set I have given girls, and the mapping there or the function it is only mother. So each and every child somehow in my domain definitely will have a mother, no? So therefore, none of the child will be left free in my domain set. That is the intention here. So if I just think over that analogy, this 3 has not been mapped into any of the domain, codomain set. So therefore, it is not a function. Understood now what is a function? So function is very simple. We have like characteristic function. Characteristic function. So no, we know what is a function. What is all about the characteristic function? So that function has some characters. So what are the characteristic function? So that function will have some specific character or some special character. What is that characteristic function? We'll just see here. So now this characteristic function, I can define it to be as f of x is equal to, right, 0 if x belongs to the set, if x does not belong to the set A, and is equal to 1 if x belongs to the set A. Say for example, if my set A is equal to, I may have it to be as 1, 2, 3, 8 and 9, say for example, right? If these are the elements in my set A. Now, whenever I find an element in, so if I find 1 here, so therefore that element is present in the set. So therefore the function will have the value as 1, right? And next is, I will have to see it, x is present in A, 2 is present here, so therefore it will be 1. 3 is also present, but then 4, 5, 6 and all it is not here. So therefore in that place I will be giving it as 0. So characteristic function, what it says is that it has some special character. What is that character it has? So whenever I find an element in any given set, in that case the function will take a value as 1. If not, it will take a value as 0. So can you recall and can you just map or can you just relate this to a truth table? Yes. So this is a special kind of a truth table. Let me explain that also. Right here, so I may have x and I may have the function, that is function p of x or f of x, whatever it may be the term. So here, let's see here, I have numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right. Now, if is 1 there in the set? Yes. If an element is there in the set, then the function takes a value as 1. Yes, good. And 2 is here, then again if an element is present there, the function takes a value as 1. Again 3 is present, so it takes a value as 1. See here 4 is not present here. So whenever any element is not present in that set, the function will take as what? 0. Again 5 is not there in this set. So if it is not present in that set, it will take a value as 0. Likewise 6 also it is not there in this set. So whenever any element is not present in that set, the function will take a value as 0. And then again 7 is also not there. So then that will be equal to 0. And next is 8. 8 it is present here. Whenever an element is present in the set, the function will take a value as 1. 9 is present, 0. See, look at this column now. So this column has ones or zeros. So it looks like more or less a truth table, right? So therefore, this characteristic function is a special kind of, it is a kind like truth table, right? Or truth values. So this is what about the characteristic function one should know. And next is composite function. Composite function. So composite function in the sense, how do we define this composite function? We know what is a function. What is composite? Composite is one over the other or one after the other. So suppose for example, if I have a function f from x to y, say, right? Let f be a function from x to y. Then and g be a function from y to z, right? G be a function from y to z. Then what is all about h, right? H will be a function from x to z, x to z. So let me explain how this h becomes a function from h to x to z. So now h, it is called as the composite function. H is equal to, I can write this to be as g composite f. So this we will have to work out from the reverse order, right? Like h is equal to g composition f. So now f is from what? X to y. See here I have x to y. This is my function f. And y, it is a function from y to z. G is a function from y to z. What does h say? H, it is a function from x to z. Let us see that. So it is h is equal to g composition f. So f of what? So you will have to see the domain element. So domain element is what here? X, right? So now this is equal to, I can write it to be as g of f of x, right? G of f of x. It can be written like this. So composite function is f, it is a function from x to y, g, it is a function from y to z. Here we have, then the composite function h will be from x to z. So how it is from x to z, that we will have to see here, right? So now g composition f of x, that is equal to g of f of x. So g of f of x, what is our f of x? So f of x is nothing else but here in the domain set, right? So I have here x, I have here y, right? F is the function. I have the elements x1, x2, x3, y1, y2, y3 and so on. See here f of x1 is equal to some y1 is in case if it is mapped na. So this is nothing else but this f of x will be here in my domain set. So that it will be equal to g of y. So now let us see what is this g of y. See, g is a function from what? G is a function from y to z. So each and every element of y, here it will be mapped onto some values of z, right? So if I take that way, then g of y, it will take a function or it will take a value in my Z, codomain. So this it is nothing else but Z. So now H it starts from, so from where it starts with the domain. So now we see here H, it is a function from X to Z. So this is how a composite function will be defined. So not only this, let us see some more functions also. Suppose for example, if I have a function from X to Y, right, let it be Y, from X to Y if I have a function, then from again if G is a function from Y to Z, G is a function from Y to Z, then again H is a function from Z to some other point, say W, then we can have right. So I can have some more function also. Let J be a function from W to V. Now, do we have a composite, or what is the composite of this? So that we'll have to see, right? So what is the, let the composite function be K. So will it be from K to V? That we'll have to see. So we'll check here. So now K is equal to, we'll start with X now. K of X is equal to, how do we write it? So this we'll write it as what? V composition, J composition, right? V composition, J composition, H composition, G composition, F, 3 braces of X. So this is V of, J of, H of, G of, F of X. 1, 2, 3, 4. 1, 2, 3, 4 braces. So which is V of, see here, J of, H of, G of, F of X. So F of X na, this function maps X onto Y. So F of X I can have it to be as some Y, right? So this is Y, which is V of, J of, H of, G of Y. So G maps Y onto some Z. So let me have it to be as Z. So next is V of, J of, so from H maps from Z to W. So I'll have it to be as W, right? So which is V of, from J maps W onto V. So W onto V na, I'll have here what, right? So I'll have here V, I can have this way, right? So J of W, J maps onto this, right? So therefore we see here K, it is a function from X to V, right? Understood? So this is how we can define any composite function. So now we have seen what is about function, and then composite function, then we have seen characteristic function. Now we'll suppose if a relation is given, how do we find that relation to be a function or not? That we have understood what is all about function. So function means each and every element in my X has to be uniquely mapped onto my Y under any mapping, right? So now if I take that way now, I have R1 is equal to 1, 1. See here, what is my domain? Domain is 1, 2, 3, 4. So you have the domain. Codomain we'll have. So the relation, we'll have to say whether this is 1, 2, 3, 4. Whether this is a function or not a function, you will have to help me out in this. So 1 is mapped onto 1, right? 1 is mapped onto 1, 2 is mapped onto 1, 3 is mapped onto 1, 3 is mapped onto 3, right? 4 is mapped onto 1. So you will have to tell me this is 1, 3 is mapped onto 3, and you cannot, so okay, right? So now this is my domain and this is my codomain. So is this a function? Is this R1 becomes a function? You will have to tell me. See here, you just recall that analogy. So what is that analogy say? I can have all these elements mapped to one single element. That is possible. But this 3 cannot have two different mothers, right? A child cannot have 2 mothers. So therefore, this since because this is ruled out, you can just remember that analogy. So therefore, R1 is not function. R1 is not a function. Next, come on to this relation we have, right? So, we have x, we have y, that is domain and codomain, domain, codomain, and here we have the relation R2. So, what are all the domain sets we have? Domain elements we have 1, 2, 3, 4. So, these are the domain elements. Now, let us see 1 is mapped onto 2, 1 is mapped onto 2, 2 is mapped onto 3, 2 is mapped onto 3, 4 is mapped onto 2. So, is this a function? What did I say you in the function? Each and every element of my domain should be uniquely mapped onto my codomain. So, does it satisfy, or even if you still have any confusion in that, remember that analogy. So, what is that analogy says? Each and every child will definitely have a mother. So, this is left out, which is not possible, and it is not a function, right? Understood? So, therefore, R2 is not a function. So, this way one can remember. And next is R3 is this. So, I will have my domain set, I have my codomain set. This is domain, this is codomain, and I have my relation R3. So, what are all the domain elements? I have 1, 2, 3, 4. And I will have to see this relation is whether a function or not. So, 1 is mapped onto 1, 2 is mapped onto 1, 3 is mapped onto 1, 4 is mapped onto 1. So, does it a function or not? I will have to think over. So, here all the child may be related to same mother, that is not a problem, no issues. So, therefore, automatically this R3 is a function, right? R3 is a function. And next see R4. So, if we see R4 now, we have domain set, codomain set, and R4 we have here. And what are the domain elements? Compulsorily one has to write all the domain elements, right? So, 1, 2, 3, 4. 1 is mapped onto 4, 2 is mapped onto 3, 3 is mapped onto 2, 4 is mapped onto 1, right? Is it a function or not? Definitely this is a function. Each and every element of my domain has been uniquely mapped onto my codomain. So, therefore, R4 is a function. So, this is how one have to classify whether a function is, whether a given relation is function or not, right? Thank you. Next is, how do we find out the domain and range of any given function, right? So, what did I say you in at the beginning? Domain is nothing else but all possible input values, and range is nothing else but all possible output values. You just think of a machine. So, in a machine some process will be undergoing. So, for that it needs an input, we will be giving an input and it gives us an output. So, that is function. So, for that function all the input values which we are giving will become the domain, and whatever output the function gives us, it becomes the range. So, with that in our mind, we will have to find out, once if a function is given, how do we find out what will be the domain and what will be the range of the given function. So, for that I will give you the tips. So, 4 tips one has to follow in order to find out the domain and range. So, in case of the domain, the first thing is that, first point what it says, the function can't be divided by 0, right? So, definitely it cannot be divided by 0. That is the first point. Second point is that it cannot take square root of negative numbers, right? So, we cannot take square root of negative numbers. That is the 2 points we will have to keep in mind while finding out the domain. So, the first point, what does it say? It cannot be divided by 0, and then we cannot have square root for negative numbers. Range, what does this say? So, square roots cannot be negative. So, square roots, it should be only positive and it cannot be negative. That we will have to keep in mind. And the next point, it says that any given function should not be equal to 0, right? So, either the function may be f of x or it may be 1 by g of x, whatever may be the term, it should not be equal to 0. So, these are the 4 points which one has to remember to find out the domain and range of any given function. So, coming on to the scene, find the domain and range of the function f of x is equal to, so f of x is equal to 1 by square root of x plus 3. So, now we will find out the range and domain of this function. First, let us find out what is the domain of this function f, domain of f. So what does the first point say? It can't divide by 0. Fine, okay. So next is it cannot take square root of negative numbers. So we cannot have square root of negative numbers. So therefore, what should I do? So it cannot divide by 0, no? So it cannot divide by 0, na? It should be what? Not equal to 0. So if it should not be equal to 0, I'll have to find, na? So x square root of x plus 3 should not be equal to 0. Cannot divide by 0. Or x plus 3 is not equal to 0. Or I can say that x is not equal to minus 3. So the domain here, it is nothing else but, what's the domain? See here, domain is nothing else but it will take all values of x except minus 3, right? All values of x except x is equal to minus 3. So if I take minus 3 na, here it will become 0 and 1 by 0, anything by 0 will become infinity, and that it violates the rule. So therefore the domain is the domain of a function here, it is nothing else but all values of x except x is equal to minus 3. So we can have the range here in a number lines. See, just see here, domain it can vary from negative infinity to positive infinity, and I say that all values of x except minus 3. So somewhere minus 3 I will have. So the domain normally it will be from minus infinity to plus infinity, but for this problem specifically we will have to find it. So now, so suppose in case if my x is equal to minus 3 na, what do I get? It becomes 0. So which will not happen. So therefore my domain will take a value from this to this, minus infinity to minus 3, right, open interval, and union I can have even have greater than that, right? So sorry, I cannot have the domain here, no? So except at minus 3 is equal to 0, right? So x is not equal to, it is square root, no? So it should be greater than 0. So even if I have negative here, so minus 4 if I have now, I'll have it as root of minus 1, that cannot be, that cannot have here. So therefore here I should have it to be as greater than 0, right? Greater than 0, greater than 0. So this becomes greater than minus 3. So it should be all values of x. So what happens in case if I take minus 2 or minus 4 now, I will get it to be as root of minus 1, which violates this point. So therefore I can have above, that is the domain will be from minus 3 to infinity. What happens if I take minus 3 here as a closed interval? So if I include that point, I will get it to be a 0. So therefore it will become infinity, which violates. So that is the domain of the function. So the domain here is minus 3 comma infinity. Then what is the range? How do we find out the range of the function? Square roots can't be negative, that is one point. Square roots can't be negative, so which means that it should be positive, right? Square root range, square roots should be positive. So x plus 3 greater than 0, f of x is not equal to 0, or 1 by g of x not equal to 0. So this should not be equal to 0. So if it is not equal to 0 na, it should be greater than 0. Suppose for example if I take y is equal to f of x is equal to 1 by root of x plus 3. So this square root of x plus 3 is greater than 0. So if it is greater than 0, definitely this will be also greater than 0. So the range of y here is nothing else but y is greater than 0. That is range of f is y greater than 0. That way I can say. So this is very simple, and we will just see few more examples of how to find out the domain and range. So range is very simple. Find the domain of the function f of x is equal to 2x minus 7 divided by square root of x plus 3. How do we find the domain? So domain says that 2 points we will have to keep in mind. Can't divide by 0 and can't take the square root of negative numbers. So now we will see the solution here for the first one. So domain of the first function, which means that it should not be square roots should be a positive number, so it should be square root of x plus 3 should be greater than 0, and this implies x plus 3 is greater than 0, and this implies x is greater than minus 3. So then we can have the domain of that function to be as minus 3 to positive infinity, right? And next function we have f of x is equal to that. See here the numerator, what the domain says, can't take square root of negative numbers. Square root of negative numbers is not permitted, which means that square root of x minus 4 should be a positive term. So this implies we will have x minus, or squaring on both the sides, we have x minus 4 is greater than 0. This implies x should be greater than 4, right? So what happens if it takes less than 4? Now I will get negative, and that violates this point. Keep that in your mind. And next is we have x square minus 25, that is any function, it also must be greater than 0. So, or greater than or equal to 0 also, if I had, I can take greater than 0. So, this implies x plus 5 into x minus 5, right. So, x square plus minus 25 can be written this way. So, this is not equal to 0 also I can write, right. So, not equal to 0. So, which means that x is equal to minus 5 plus 5. So, at this point minus 5 and at the point plus 5, I cannot have the domain since because it becomes infinity. Now see the number line. Number line, this is negative infinity to positive infinity. I will have minus, so here I have minus 5, I have 4 somewhere here, I have 5 somewhere here. So we will have to check, right. So if it takes lesser values from this point to this point, if it takes lesser value, what happens? See here I have minus 5. So, minus 5 if I substitute it, or minus 6 if I substitute, what do I get? So, minus 6 na, I will have minus 6 plus 5. So, minus 6 plus 5 is minus 1 here I will have, and minus 6 minus 5. So, minus 6 minus 5 is minus 11. So, minus to minus becomes plus, so it is greater than 0 I can have. So, what happens if it takes this value? So, minus 5 to 4, in between this I can have 3. So, 3 if I have na, 3 plus 2 is 5 is 8, 3 minus 5 is minus 2, right. So, which is less than 0, plus into minus is less than 0, here I cannot have. So, what happens if I take in between this value 4 and 5? So, suppose in case if I take it as 4.5 say, 4.5 na it becomes 9.5. And here 4.5 na I will have it to be as minus 0.5. So, I will have again a negative value, here also it will not have the domain. So, whereas in case greater than 5, how do I find the domain? So, 6 if I give na, 11, 6 minus 1, okay, here I will have the domain. So, therefore, my domain of this function will be from negative infinity to minus 5 union 5 to infinity, right. And again this third one we have, so now we will just see here, this should not be equal to 0, that is x square minus 9x plus 20, this should not be equal to 0, which means that we will factorize. So, x minus 4 into x minus 5 is not equal to 0. If I make a product, I get it as plus 20, and when I add it, I get it as minus 9. So, x is not equal to 4, as well it is not equal to 5. So, I will draw the number line here, right. So, we have negative infinity to positive infinity, 4 we will have here, 5 we will have here, right. So, now if I give the value as below this, if I give it as 3, what happens? So, 3 minus 1, as 3 minus 4 is minus 1, and 3 again, so it becomes a positive value, fine. And suppose in case if I give between 4 and 5, so I cannot take 4 and 5. So, 4.5 if I take na, 4.5 positive, 4.5 negative, so that range it will not have. So, this range I will get, this range also I will get, but here I will not get. So the domain of this function is, the domain is negative infinity to 4 union 5 positive infinity. So that becomes the domain. So that's all for this session.